All right, here we go. I'm just going to really quickly pull up our YouTube channel so that I can see what we are doing. All right, hi folks. Welcome everybody to today's meetup / live stream with John Green from Night Shift Development. We're really excited to have him here today to talk about tracking option trades with the Elastic Stack. Super excited to dive in with him and hear from him today. He also presented at our Elastic Community Conference back in February, so we're really excited to welcome him for a second time and go into a little more detail on this particular topic. Really quickly, I want to mention if you guys have any questions throughout the live stream, please throw them into the chat. We will go through those questions at the end, but really, whatever you have, we're happy to chat through it. So without further ado, I'm going to hand things over to John, and I'm going to share his screen really quick. All right, John, over to you.
Hi, everybody. I want to express how excited I am to demonstrate a tool I built around a hobby of mine that I actually really enjoy doing. And so I want to thank everyone for joining me today. And I want to thank the Elastic community for having me back to demonstrate and go over the technical details on how I used Elasticsearch to track my option trades, specifically on the obligatory side of contracts. Now, I will not be discussing details on how you actually trade an option or options in general, or how you make a trade plan, okay? Other than trade plans are just ways for traders to control and wrangle in their emotions when they're in the heat of the market. Now, this is solely to demonstrate a collection of technologies I quickly brought together at a beginner to intermediate level to ingest and visualize my option trade performance. So it's clear, anything presented or said is not financial advice of any kind. What is being presented is how I personally use these technologies to track my option trading performance and nothing more. And I do want to express that there's no guarantee that this method would be successful for you. If there is anyone joining today who's actually familiar with selling option contracts, you know you're being chased down by a steamroller while picking up change off the ground. You're familiar with the obligatory side of actually writing options and the risks that come with them. You know one bad trade can actually eliminate several months of work to a year of gains, and unfortunately, sometimes a lot more. So what was the problem I was facing? So what I found is online brokers have to cater to a plethora of different clients' needs, okay? They provide an extensive array of awesome tools, which I actually do enjoy using. But however, I wanted to build something that was really tailored to me and my needs, something that could just bring it all in one spot. And being fairly new to selling option contracts and empowered with my data engineering background, I needed a tool to visualize my trade performance and guideline compliance all in a single location, almost like a heads-up display. One which I could verify my trade plan execution over time and by equity. I needed to answer that looming question that every trader falls into is, gee, how well am I actually really doing? So I wanted it really simple. I wanted it easy to do and easy to build, almost prototype-like. So it's not a cluster, and I didn't have to do any extensive buying of hardware, okay, or any extensive tuning. But what I also wanted to demonstrate is this can actually easily be converted to potentially handling thousands and thousands of trades. And it does lay that foundation. So as a data engineer and a data scientist, okay, we know it starts with the data. And illustrated is an actual snippet of a record, which is a trade, or an actual report of a trade, okay? Now, trades are temporal records of various field types. Knowing my planned enrichments and the amount of data that I could potentially handle over time, I built out an actual index template with mappings to support aggregations, which then would drive the visualizations in Kibana, filters and using Kibana filtering, and then searching, as well as eventually index management. This incorporated keywords, dates, and float types, along with a white space analyzer for equity searching, as illustrated. Now, I want to briefly answer a question as to why an index template. Index templates is a way that every time you do create an index, and if you want to partition your data out like I do by year and have a specialized index for that year, you define a template that's applied each time on every index that's created over the course of time. Okay. And if you then take this and scale it to thousands of trades and over a 5-year period or a 10-year period, eventually you may hit hardware constraints if you do. And maybe you will find yourself on occasion wanting to turn one of those indexes off, which they call closing the index. Therefore, your data is not there anymore. It's just not available for real quick searching. And you can bring it back and it will re-index that data, and then you can perform other types of analysis on that past data. But let's also discuss why I chose a white space analyzer. As illustrated, options have a very unique symbol. If you look at what's demonstrated in the security column of the data, you can see where it has spaces that delimit very important information that traders who trade options really focus on other than option Greeks. So I wanted to be able to tokenize that data, break it up by that space. And that's what the white space analyzer allows me to do, so that I can search on specific combinations of each of those independent pieces of the name of that actual security. So now let's go, oh, sorry. And this was actually a demonstration of the white space analyzer. So here you can actually see where I wanted to ask a question of how often I struck contracts at $20, meaning I had to secure $2,000 worth of cash in order to do this. And then I can then look back in time and say to myself, should I have just bought the 100 shares if now the stock is trading at maybe $40? And I can also get a sense of which equities that happened across. Okay. So next, which was the real exploration on my end, and specifically because as a data scientist, I use Python a lot, and I also use pandas a lot, pandas data frames specifically. And if you're familiar with other libraries in Python, and if you've ever used things like Jupyter Notebooks, sometimes having to use and bang out code for your visualizations just to get a simple histogram or a word cloud, it can be daunting. And so what I wanted to be able to do as a data scientist who's familiar with the Python and the pandas data frames is I wanted to process my data and enrich it with Python, but then I wanted to visualize it with Kibana, because Kibana allowed me that ease in generating those visualizations and those aggregations. And so loading the data into Elasticsearch with Python is actually really easy. It's not that difficult. And with the illustrated Python code, I prepared and then I enriched and then ingested the TSV formatted data I was provided through my brokerage API into an Elasticsearch index. Now, do note that Python's library is a wrapper around the Elastic REST API. So now that I've jammed the data up into, or I inserted the data up into Elasticsearch, I started visualizing my trade performance and my guideline adherence. Okay, so as illustrated, for example, by bending my trades as wins, if their proceeds exceeded 0, this would allow me to compute my win ratio. Further, it could then create a filtered metrics visualization, which computed the total gains and losses over a specific period of time for either the entire portfolio or an actual given equity. Now, in regards to my trade guideline compliance, I carried this on utilizing filtered bucketed aggregations that I could visually represent the total days in trade, and percent gains distributions across all my option trades. So just to conclude the slide deck, it was really easy. And again, I can't iterate enough that I actually wanted this just to all run on my home computer, on my local laptop. And if you have any other questions after this, you can reach out to me at john@nightshiftdevelopment.com. And if you actually want to see how this tool was demonstrated in monitoring cash secured puts, looking for emotional trading, through Night Shift Development, I published on medium.com an actual publication of how I did that. So I'm going to minimize my slides here. And what I wanted to do was go over the actual starting like I did earlier with storing your data and the importance of data, and actually go over the index template. So again, keeping in mind that I wanted to be able to scale this out later and also potentially break the data out into different types of indexes and applying different types of fields to different types of transactions. I defined a template started at ordered 0 and an index pattern with anything that started with TDA star. What this allowed me to do was, right now, I just do TDA portfolio and then the year as I extrapolate that from the data. However, if I wanted to later break this up into like stocks, bonds, and options and create indexes for each one of those, I could just do TDA underscore stocks underscore the year. And then because of the order, and this is something I ran into in my career, the importance of that order is then now I can say in an index, I can apply a secondary template on top that comes after applying the first. And that's why I specify an order of 0, is because when I decide to then do stocks, I can then define a separate index template ordered at 0 and not have to replicate all of this. I can just specify very unique things to maybe stocks, and it gets applied second and later. Now, setting up an actual white space analyzer on the actual name itself of the contract. So this is how you would simply specify your white space analyzer on a field, as well as making it a keyword. This tells Elastic, when it indexes the data, to tokenize that particular field based on the white spaces. And so now what I'm going to do is demonstrate the importance of why I did that. So before I built out a visualization, I needed to explore my data. I needed to find out certain patterns in my data. And so if I wanted to, as an options trader, we tend to focus a lot around that symbol, because that symbol has a plethora of information that not everybody knows is very important. And so things like, what is the underlying stock that derivative is trading against, which options are called? What month was it? Will it expire? What day it will expire? As well as what year it expires, and then what price I'm negotiating a particular obligation or right against, as well as what type of contract I'm actually trading. So if I take in context, using the white space analyzer, and I wanted to be able to do this against just literally a single field and not have to remember every single field in the index to do this, and to get different types of aggregations on or different types of search patterns on, I could just literally say security and say, let's find out, like, if in history, which ones did I trade that required me to obligate $2,000 to. I could look at all of those transactions and see which ones those were, and which equities they were against. So now I can see at one time, Bank of America, I struck it at 20. If you look at the stock today, I could then ask myself, which I think, and please don't quote me on this, I think it's trading around in the 30s somewhere. I could have then said, well, why didn't I just buy 100 shares of it at that time? And then you can go on further to actually drill down. Let's just say I have hundreds of thousands of records here. And I'm not going to scroll through every single one of them, but I can't seem to find any calls. So what I can do is I can say, did I ever write any calls? And unfortunately, I did not at that particular strike price. So moving on from the actual storing of the data to why I used a white space analyzer to be able to search the securities for any type of data exploration capabilities, let's move on to the next part, which is actually getting that data into Elasticsearch with Python, which was the real meat behind this whole system. And so I'm going to bring up the actual Python code and express two important functions within my Python. Now, the function that ingests the data into Elasticsearch takes a pandas data frame as well as a name. And the name, which I define as Elasticsearch index, is extrapolated from creating a base name, which if I quickly go back to the index pattern, or template, I should say, sorry, there is an index pattern of TDA star. So when I specify TDA portfolio underscore, it's going to now say, hey, there's TDA in the name, apply that index pattern upon creation of that index, or template, sorry. So go through my data, get the year, create the base index name, and then pass it to the indexing process. So here was the fun part. I needed to generate a unique ID to every single record that I'm receiving, every trade that I've done. And every trade on the stock market is like footprints in sand. There are those temporal records. And so all of the data there is together, and all of the fields together make that unique footprint. So before I can index this data, I have to first instruct the Python code to say, with a requirements.txt file, that, hey, I want you to use the 7.0 API or greater. And because that's the version of Elasticsearch that I'm using. Then from there, it is establishing the client, passing the data frame, establishing the client, and then now checking for that index name. Once I checked for that index name through the indices index call, it allowed me to say, are you there? If you're not, create it. And once it creates it, it uses that index template to apply those features onto the index, the settings of the index, as well as the actual mappings for each of the fields. But here was the cool part as a data scientist, dealing with data frames a lot for a lot of the stuff I do. And I usually use data frames to build out visualizations. Well, now I have Elastic at my disposal with Kibana to do that. And now that I have just these few lines of code, now I don't have to spend my time visualizing things in a Jupyter notebook for presentations. I can actually just say, you know what? I'm going to use these few lines of code, put my data up into a pandas data frame, iterate those rows, and send them up into Elasticsearch. And then I can build a dashboard to present. So what I ended up doing is I just iterate through the rows, and a document is returned during that iteration. Well, I want to point out the importance of this piece when hashing a row out of pandas, okay? Is that the series, oddly enough, I was running into a bug with my tool, and I could not understand why I was getting duplicate records. Well, it was based on the way that I was hashing just the series alone on times that I would run this code. And then I realized, oh, I can't do that on the object instantiation. So basically what I said is, let me just convert the entire thing to a string, make sure that I do not include the index of that row and the headers of the actual pandas data frame. And then I could hash it as a string, and that generated that unique key that you need for the Elastic index that I know as _ID. Once I did that, I didn't want to update records. I didn't want to smash. I didn't want to just keep hitting my Elastic instance with update, 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 update for every record, because the data I get through my broker's API generates a yearly report each time. So I'm getting duplicate records all the time. And so I didn't want to keep hitting that instance with updates all the time. Because if I go to scale and I'm doing that could be sometimes troublesome, you know? So, and cause an extra amount of work on the instance if it's dealing with a lot of other things at the same time. So what I do is I simply check for existence. Once I check for existence, if it's not there, then I insert it. But what's important that I do want to point out to individuals is that make sure you don't return the entire source back just to check to see if you're there. You don't want, to just call out to a crowd of individuals and they yell out to you that I'm here, and then they are also walking back to you to the podium, okay? You don't want to have to do that. You just want to hear the voice of, hey, I'm there. And so just specifying the parameter _source equals false reduces the payload and network traffic back to you when you're ingesting data into the system. Now, once you identify that your record is not currently there and you need to ingest it, the beauty behind this API is it's just simply this one call of ESIndex. You give it the name of the index you want to put it in. You give it that unique hashed record ID, or however you want to define that ID. And then the beauty behind it is Python dictionaries are like little independent teeny JSON records in a way. They're key valued paired, almost formatted like a JSON record. And so it was as simply as just saying body equals document to dictionary. And it took and converted that pandas row right into a little teeny JSON record, and right up into Elasticsearch it went. And then from there, all you really have to do is just say from Elasticsearch, import Elasticsearch. And then that's it. So what I will do is I'll actually demonstrate the application loading data, or the code actually loading data into Elasticsearch. So I'm actually going to delete my indexes and get rid of them. And then I'll use the cat indices to look for anything that's TDA star to see if it still exists. Nope, they're all gone. Oops, sorry. So now what I will do is I will actually run the code, which will go to a directory, pull out using glob, and go through each of the files and ingest them into the indexes. And as you can see, it went through and it reports back to me, this is the file I processed. I'm cleaning the data. And then, oh, it did identify that it has to create an index. It tells me what that index name is. And then it returns back the number of records that it actually indexed. If I go to run this again, that exists check along with the hash will tell me, nope, there's nothing for me to ingest anymore. So from there, I can now check, do I have the data in the Elastic index? I do. I have two indexes, or two, for both 2020 and 2021. So now we have the data. Oh, sorry. And now we have the data available. And I'm going to do a search back from January 1st, 2020 to now. And from here, you can actually see the dashboard and how I now have this heads up display that indicates to me, well, am I growing in money? Yes, good, that's great. That's what we would love to see. How am I distributing in my gains over my trades? If I have a particular trade plan where I say I have to be over 40 before I'm supposed to close a trade in terms of gains, and I should say 40% gain, then this now tells me, wait a minute, why am I under 40? Okay. And what is really great about a Kibana dashboard and the visualizations you build with the Kibana dashboards is the ability to drill down without having to write the complex, some of the queries that you would want to have to write in the actual development tool to get the data back. You can just simply just say, you know what, I really want to know why I'm under 40% here, why I have so many that are almost equal to this. And I can just click on this and I can see right away the top 10 equities that did not meet that one trade plan rule. And then I can then get a quick look at the records and see, which records were actually in the index that fell under 40%. And then were any of them losing trades? And as you can see, there actually aren't any. And then this is where you can actually say, okay, well, now I want to drill this down by an actual equity or that this derivative is on to see the actual performance. And as you can tell, I actually do a lot of option trades against a particular equity. And I can see my distribution of how long I'm in those option trades, and I can get my win ratio. And so far, since January 2020, none of my option trades, as illustrated here, actually went wrong against this. Now, that white space analyzer that I used against the security tab actually can be combined with this Kibana visualization to also do things like, if I don't have a particular visualization that I can use to drill down, I can just say, you know what, I want all my Bank of Americas that have a month that starts with an M, and I can see now here are all those trades. Well, when I mean by month, the actual expiration of the month and when those trades were actually happened. So for May contracts, I was actually trading in April and March, and sometimes in February on those contracts. And so that was basically the demonstration of and the story behind why I developed this and what the underlying product was at the end of this, how I utilized Elastic's index template. And then most importantly, what I wanted to do as a data scientist is be able to push that Python, to use Python code and take my data and push it up into an Elastic index and visualize it with Kibana, and then be able to build out a dashboard to present to anybody that I needed to present my findings to. And so that concludes my presentation.
Awesome, John. Thank you so much. This was super interesting to see, and obviously the impact is that you're able to track and measure success pretty easily, which is awesome. Well, I don't see any questions in the chat. You're definitely getting a lot of shout outs for giving a really great presentation. But folks, we do have a few minutes if you have any questions for John about his presentation today. I did see somebody ask for your slides, John, so we'll need to connect about that.
All right, cool. Thank you.
Somebody's asking if you are going to share the Python code.
Yeah, I can make it available if anybody wants to. My email address. So if you can shoot me the individuals who want to use that Python code to ingest into from pandas into Elasticsearch, I would love to share that. So
it's john@nightshiftdevelopment.com, right?
Yes.
Okay. Awesome. Great. Well, if there aren't any other questions right now, we'll go ahead and end the broadcast. But John, thank you so much. This was such a great presentation and really cool to see. So thank you again.
Yes. Thank you for having me back. And I really enjoyed sharing this with everybody. Thank you.
Yeah. Awesome. All right. Well, thanks for joining, folks, and we'll see you later.
Bye.
Bye.